Good afternoon. We are going to take some brief notes, Trig Point 3, our third day, and these are just some problem-specific notes from things you're going to see on the worksheet, and I just wanted to make sure that I went over some of the things you need to know. So we're going to just do a few examples and how to approach them. Okay, so one example of a problem you're going to get, they're going to give you a degree measure, and they're going to want you to change it to radians. And then they're going to say they want it to be a multiple of pi. So of course the first thing you need to know is what are they talking about to be a multiple of pi? Well, being a multiple of pi means two things. First, your angle measure must be positive. And second, it must be exact. So we're talking fractions. And because we're talking multiples of pi, automatically your brain should go to radians. All right, so the example we have is, let's see, the measure of an angle equals negative 60 degrees. And we're supposed to change this to a multiple of pi. So first thing we need to do is to change from degrees to radians. Okay, let's do that. So take your negative 60 degrees over 1. We're going to multiply it by our conversion, and we know that pi radians equals 180 degrees. I want degrees to cancel, so the 180 will go on the bottom, and the pi radians will go on the top. That way, degrees and degrees cancel out, and that gives us negative 60 pi over 180. Take a 0 off. That's basically negative 1/3 pi, or negative pi over 3 radians. So we've done the first thing, which is to take the degrees and put it into radian form. Okay, now we're going to figure out what it's going to actually be. So let's do a quick little graph here. And so you know that 0 radians is to the right. So when we're talking negative pi over 3, we're talking this direction. We're actually going to go in the negative direction, and this is negative pi over 3. The reference angle is pi over 3. Okay, so we need to change that to something positive. So the positive multiple of pi will go in the positive direction, which is around this way, and end up here. Now, when you're doing any kind of fraction of pi, it's helpful if you think in terms of that fraction, in this case, thirds. So I'm going to use a different color here. So pi over 3 is going to be our counting unit. So pi is over here. So 1/3 of pi would be here. That would be pi over 3. This would be 2 pi over 3. This is 3 pi over 3, or just pi. And then we're going to keep counting by thirds. So this is 4 pi over 3, which means this one has to be 5 pi over 3. And that is our answer, because that is the same angle, except as a multiple of pi, positive and going by thirds. So I call these our little pinwheels. You're going to do a lot of counting on pinwheels. So you're going to go by thirds or sixths or fifths, and you're going to split pi into that number of pieces and that number of pieces and count to figure out where you are. That is the easiest way to do it this early. Later on, you're going to get a lot better at it, and you'll be able to do it by subtraction. You'll have to convert 2 pi into whatever fractional units you're going by and subtract your negative angle from 2 pi. All right, so that's the first example I wanted to go over, is how to put something into a multiple of pi. All right, example 2. Let's say one of your questions is going to say, sketch the angle negative 54 degrees, 45 minutes. Okay, so in order to sketch the angle accurately, you need to do two things. Convert to degrees, and typically you will need to find the reference angle. Find the reference angle. Okay, so let's do the easy part, which is to convert to degrees. The 54 is fine. I need to take 45 minutes over 1, and I need to go to degrees. So there are 60 minutes in a degree, so 1 degree over 60 minutes. So minutes cancel out, and I've got 45 over 60 degrees, which is 3/4 or 0.75. So my angle is negative 54.75 degrees. All right, so we're going to sketch where this angle is. So when you sketch an angle in space, you can't just like randomly draw a line and label it. It doesn't work like that. You need to give the reference angle back to the nearest x-axis. So remember, reference angle is to the nearest x-axis. So I can say 54 is more than 45. We're definitely going in the negative direction from 0 degrees. So about here's 45, so 54 will be about here. So the actual angle is negative 54.75 degrees. What we need, however, is the reference angle. So if this is 0 degrees, this is negative 90 degrees. And sometimes, sometimes in this case, the reference angle is going to be the same. Other times you're going to have to subtract. In this case, our reference angle really is, so I'm going to put reference angle is 54.75 degrees. Now, if you're trying to get a good graph off of this, what you would want to do is measure 45. Let me change colors. So if this is 45 degrees, and then half of 45 is 22.5. If you add that, you get halfway here, which is your 67.5 degrees. I should make both of these negative. So your 54 will be somewhere in the middle of those. So if you're not sure where to put it at all, find 45, find halfway in between 45 and 90, and in between there you'll set your angle for a pretty darn good job. Naturally, you could use a protractor and measure it that way as well, but with the decimal, that's not going to be super exact anyway. I know this wasn't a very good example of a reference angle. Let's say that you have to graph, let's say example 3. We'll use the same grid, and you have to graph something like, I don't know, 187 degrees. So if I graph 187 degrees, 180 is over here. Of course, we're going in the positive direction. So 187 would be pretty close in. That would be your 187 degrees. But you would need to find the reference angle. So first you want to subtract out this part. This part is 180. So 180, I don't need a calculator. 187 minus 180 is 7 degrees. So from here to here, your reference angle would be 7 degrees. So this is your actual angle. This is your reference angle. And the reference angle is going to take on more and more importance as we go along in this unit. So I wanted to make sure that you know the difference between a reference angle and an actual angle. Okay, flip the page. Last example. We'll call this example 4. Just a reminder that planes and ships use what they call bearing heading, direction. Bearing, heading, and direction. They all basically mean the same thing, and these are measured from due north and from north clockwise are positive angles, and counterclockwise are negative angles. Okay, so let's draw a pair of axes. Okay, so one of the types of problems that you're going to get is they want to know what is the plane's bearing if its angle of flight is, and they'll give you something like 110 degrees, 23 minutes, 16 seconds. All right, and you want to know what its bearing is. Okay, so first thing you'd want to do is convert that to a decimal form that you can actually work with. We just went over that, so I'm not going to do it again. But you'd convert it. It ends up being 110.3878 degrees. And here is 0. So if it's actual measurement, 90's here. So 110 will be somewhere up in here. That is your actual angle, which is 110.3878 degrees. Now, because it is a plane, we have to figure out what is the angle from due north. So we already know it's to the left of north, so this is going to be some kind of a negative theta. We just have to figure out what. Well, this angle here is 90 degrees. So if we take the 110 and we subtract 90, what's left is going to be your theta. So 110.3878, subtract it from 90, we get 20.3878. So let me write this over here. So we go 110.3878 degrees minus 90 degrees is 20.3878 degrees. That will be our bearing. It's a bearing of, and because it's going left of north, it's going to be negative 20.3878 degrees. And then who knows, do they want it in degree, minute, second form, or can you just leave it as a decimal degree? That totally depends on the question that you're working with. So that's how you switch from an actual angle to bearing for ships and planes. Is it confusing? Yes, it can be very, very confusing. But just read the questions carefully and then make a good diagram. That always makes a difference. Okay, that is the end of the notes. Like I said, pretty brief today. Have an excellent afternoon.